Let's take a look at how to find the domain and range for a function. In this example, a restaurant is open from 2 p.m. to 2 a.m. each day, and a maximum of 200 guests can fit inside. If f of t is the number of guests in the restaurant t hours after 2 p.m. each day, what are a reasonable domain and range for this function f of t? So in this particular problem, we don't have a formula or an equation, but the function here represents the um, number of guests inside a restaurant at any given time between 2 p.m. and 2 a.m. So that's what the function represents, the number of people inside the restaurant between 2 p.m. and 2 a.m. So I usually tell my students that if you have a hard time finding the domain and the range of a function, especially when you have a word problem like this, then it might be a good idea to just make a quick sketch of the input value and the output value so you can kind of think through this problem logically. So here our input value is on the horizontal axis, and the input value in this particular problem is time. So time since 2 p.m. So that's when the restaurant opens. It opens from 2 p.m. and it closes at 2 a.m. So typically when you have time and it's given like time since a certain amount, you want to convert it to a t value. So at 2 p.m., we'll say that's when t equals 0. So t equals 0 is 2 p.m. And then if t is 1, then we're looking at 3 p.m. And if t is, 1.5, then that's 3:30 p.m., etc. Okay, so when t is 12, then that's 2 a.m. So we can see here that our domain, which is our input value, goes from 0 to 12, and that's what would make sense for this problem. So here, the domain, we can write the domain as t values between 0 and 12 hours. Okay, now let's talk about the range. The range represents the number of guests inside the restaurant at any given time between 2 p.m. and 2 a.m. So since the maximum number of people that can fit in this restaurant is 200, then we can see here that at any given time between 2 p.m. and 2 a.m., the number of guests in the restaurant can be anywhere between 0 and 200 guests. So that makes up the range of this function. So f of t is going to consist of values between 0 guests up to 200 guests. Okay, let's take a look at the next example. In this example, we want to find the domain and range of a function, and here the function is given to us as a formula or an equation. So anytime that you have a formula or an equation, sometimes I tell students that it might actually be easier to find the domain and the range if you graph this function. But if you don't have a graphing tool, then we can use a little bit of algebra. So let's remind ourselves that the domain of a function is all the x values that make this function exist. So here notice that you have a rational expression or a fraction here, where the denominator we have x minus 2. So you can start thinking of all the values that you can use for x that will give us a real number for f of x. So for example, we can say, what could x be? What if I let x be 0? Then f of 0 would be 1 over 0 minus 2, which is negative 1/2, which is a real number. So the domain, x could be 0. Then we say, okay, could x be a negative number? What if x was negative 3? Then f of negative 3, we would have 1 over negative 3 minus 2, which is 1 over negative 5, which is another real number. So x could be negative 3, and the list could go on and on. Remember, the domain represents all the values that x could be so that this function exists, meaning this function has an output value, such as negative 1/2 or a negative a fifth. So instead of thinking of all the values that x could be for the domain, right, it might be easier to start thinking about what x cannot be. So when you have a rational expression like this, we know that the denominator of a fraction could never be 0, right? Because if it's 0, then the function is undefined. So here we can say x could be any number except for the number that would make that denominator 0. So if we focus on the denominator x minus 2, what value of x would cause that denominator to be 0? So hopefully you would agree that if x equaled 2, then 2 minus 2 equals 0, which would make this function undefined. So in this situation, to write the domain, we would say that the domain, we can write it in words, oops, let me erase this, all the real numbers, so we can say all the real numbers except x equals 2. So another way to write this, all the real numbers except for x equals 2, is to just simply say the domain is all the real numbers except for 2. Okay? Now let's talk about the range. So if I can use any real number for x, right? If I use a positive number, like let's say f is positive 3 instead of negative 3, I would have 1 over 3 minus 2, which would give me 1 over 1 or 1. I would get a positive number. So we can have positive numbers as our output, but we can also see that we can have negative numbers as our output. But one thing that we definitely will not um, get is there's no way that this function is going to ever equal 0. So, and we know that it's never going to equal 0 because the denominator is 1. So because the denominator is 1 and the denominator here is always going to be a real number, you take a real number and you divide it into 1, you're going to get another real number. You're not going to ever get 0. So for the range here, we would write down that the range can be all the real numbers except for 0. Okay? All right, so I mentioned that sometimes it's easier to look at a graph to find the domain and the range. So in the next slide here, I'll show you the graph of this function. Okay, so here we have a graph of that function f of x is equal to 1 over x minus 2. So here, when you have a function of a graph, it makes it a little bit easier for us to see what the domain and the range are. So this function is made up of these two red curves, and hopefully you can see, I'll use blue here, that there is a vertical asymptote at x equals 2, meaning that the function does not ever equal x equals 2. The function doesn't exist there. So here we can see that for all x values greater than 2 or less than 2, the function, I'll use red here, the function exists, right? But right at x equals 2, we can see at that vertical asymptote, the function is undefined. So here, this just reiterates that the domain of this function, right? We can use any x values except for x equals 2. And then when we take a look at the range, okay, you can see that, and let me use a different color here. Let me use green. We can see that the function is decreasing here, and it approaches, so it's decreasing, and it approaches y equals 0, but it never actually equals 0. And same thing here. We can see that the function is decreasing, okay? As x gets more and more negative, the function is approaching 0, but it never actually equals 0 because there is a horizontal asymptote at y equals 0. So here we can see that the range represents all the y outputs, so everything except for 0. So we can see we have negative y values and positive y values, but no y values at y equals 0. Let's take a look at another example where we want to find the domain, the range of a function, and we have the equation for the function. So here, the function is the square root of x minus 2. So the domain is the set of all the input values, so all the x values that make this function exist, and then the range is all the corresponding output values for those input values. So again, we can start listing all the things that x could be, all right? So again, we can say, well, what if x was 0? Okay, now if x is 0, then f of 0 would be the square root of 0 minus 2, which here is the square root of negative 2. Now you cannot take the square root of a negative number, so this does not exist. So this means that x cannot be 0. Okay, so already I'm starting to think about what x cannot be. So what if x was, let's say, what if x was 1? If x is 1, then f of 1 we get 1 minus 2, and notice again, I'm still left with a negative number inside the square root sign. I can't take the square root of a negative number, so x cannot be 1. So we could keep going on and on like this, or we can think about, right, what values of x would cause, right, x minus 2, which is what is underneath the square root sign, right, to still be a negative number. So hopefully you can see that if x is 2, so if x is 2, then f of 2 would give us the square root of 2 minus 2, which is 0. And so x could be 2 or any number bigger than 2, because any number bigger than 2, when we take a number bigger than 2 and we subtract 2 from it, we're always going to get a positive number, and we could take the square root of a positive number. So here, to think about the domain would be all x values that are 2 or greater than 2, because it would give us a positive number that we can take the square root of. So that means the domain contains all x values equal to 2 or greater than 2. And we already saw in my little examples on the side here that if we choose x values that are less than 2, then we end up with these negative numbers inside the square root sign, and that's undefined. Okay, so then what does that give us for the range? So if we think about what the domain is, if x is always some number that's 2 or greater than 2, we get a positive number. And if you take the square root of a positive number, you're always going to get a positive number for the output. So the range is going to consist of only output values that are positive. So positive means 0 or greater than 0. We're never going to get a negative number because we're taking the square root of a positive number, so we're always going to get a positive number, meaning a number that's equal to 0 or greater than 0. So in the next slide, I'll show you again a graph of this function, and hopefully you can see the domain and the range more clearly from the graph. Okay, so here I've got a graph of that function f of x is equal to the square root of x minus 2. And so the graph of the square root of x minus 2 is this red curve here. And I hope that you guys can see that it starts off at x equals 2. So all the points that make up this graph have x values from 2 all the way out to, we can keep going, to positive infinity. All right, so there are no values of x less than 2. So the function doesn't exist for x values less than 2. And then when we take a look, so this makes up the domain. And then if we look at the range, you can see that the range is all the corresponding y values of this function, which start at 0 and it goes up. And this function is going to keep increasing if we expand our window, but it goes all the way up to positive infinity. So that's f of x. So that makes up the range of the function. So again, sometimes graphs make it easier for us to see the domain and the range of a function. One last example here. Let's find the domain, the range for x squared. So our function x squared, the domain is the set of all x values or input values that make this function exist. And the range is all the corresponding output values for those input values. So here we have x squared. So if you think about what x could be 0. So if x is 0, then f of 0 is 0, which is a real number. Could x be a negative number? So what if x was negative 1? Now we know that if we take a negative number and square it, it's always going to give us a positive number. And if we take a positive number, so let's let x be positive 1. If we take a positive number and square it, we're always going to end up with a positive number. So if we think about the domain of this function, I could put anything in for x. I can put in any negative number, whole number, or decimal. I could put in 0, and I could put in any positive number. So the domain for this function here, we would say, is all the reals, okay? All the reals. Or you can write it using set notation, as we can use all the numbers from all the way out to negative infinity up to positive infinity, okay? And then the range, again, we said the range is all the corresponding output values. So if we use 0 or a negative number or a positive number for x, we're always going to end up with a positive number, okay? There's no way that we're going to get a negative value if we put in any number for x. So this tells us that the range of this function are all positive numbers, but it could also be 0. So here we would say that the range could equal 0, and then it's going to always be something bigger than 0 because it's positive. And again, I'll show you a graph of this function so that you can see the domain and the range more clearly. So here is a graph of that function f of x is equal to x squared, and hopefully you can see here that this function has a domain that is made up of all the real numbers. So if we take a look at the x-axis here, we can see that this function, we can use any value of x, positive, negative, or 0, and it makes up that red curve. Now, when we talk about the range are all the corresponding output values. So hopefully you can see here that the output values, the y-coordinates, go from 0 and go up to positive infinity. So that's how we define the range as being equal to 0 or greater than 0.